Hello, all. Welcome back to discussion on polarization. So now we are going to discuss Nicol prism. So Nicol prism is invented by William Nicol in 1928. Okay, now what it is? So Nicol prism is basically is a device which can be used as a polarizer and as well as analyzer. So it is basically a polarizer, or it can also be used as a analyzer. Now, what is meant by polarizer? Polarizer is a device which converts an unpolarized light into a polarized light. An analyzer can be used to check the state of polarization of polarized light. Okay. Now, this Nicol prism is basically utilizing two phenomena in optics. So, the phenomena they used is one is double refraction, which we already discussed in detail, and the second phenomena it utilized is total internal reflection. Okay, so Nicol prism is basically using both these phenomena in order to convert an unpolarized light into a polarized light. Okay, so double refraction we have discussed in detail, so there is no need to revise it now here. And what about total internal reflection? That is also we have studied earlier. So I will just revise what is total internal reflection. Okay, so total linear reflection usually occurs when the light moves from a denser medium to a rarer medium. So you have to consider a glass slab, and let us suppose some light moving from glass slab to the second medium. Second medium we can take it as air. Okay, suppose some light moving from glass to air. Then here we can define angle of incidence. The angle of incidence, the angle between the incident light and the normal. So angle of incidence I denote by symbol theta. Now if this theta is greater than the critical angle, then what would happen is there would not be any refracted light. All the light will get reflected. All the light would get reflected. So this phenomena is called total internal reflection. There is no refraction at all. Okay, so here then first we have to define the critical angle. So the critical angle is the angle of incidence in which the angle of refraction become 90 degree. Okay, you might have remember Snell's law, which is given as n1 sine I equal to n2 sine R. Okay, the n1 is the refractive index of the first medium, and n2 is the refractive index of the second medium, I angle of incidence and R angle of refraction. Okay, so if angle of incidence is critical angle, then angle of refraction become 90 degree. Okay, now here the first medium is glass, so n1 I can write as ng, the refractiveness of glass, into sine the angle of incidence theta c becomes the refractive index of air, because second medium is air, then sine 90 degree. And what is sine 90 degree? This one. So therefore, the expression for the critical angle is given by sine theta c equal to Na by Ng. Okay, so in general, if you have two media, the first media refractive index is N1, the second media refractive index is N2, and if N1 greater than N2, then the critical angle is given by sine theta c equal to N2 by N1. Okay, so this is the formula for the critical angle. So once you know the refractive index of the first media and the refractive index of the second media, then we can find out the critical angle from this particular expression. Okay. Now, if the angle of incidence is greater than this critical angle, what would happen? We'll get the phenomena of total internal reflection. there will not be any refraction at all. So the Nicol prism actually using both these phenomena, double refraction phenomena and as well as a total Indian reflection phenomena, in order to convert an unpolarized light into a polarized light. Okay, now we can discuss what actually a Nicol prism is. So Nicol prism basically consisting of two prism made up of calcite. Okay, so Nicol prism contain two prism of calcite. Okay. Now they have put together these both the prisms have put together using an adhesive called Canada balsam. So two prism of calcite sticked by an adhesive called Canada balsam. So why we use Canada balsam? Why did not we use a usual Fevicol? So that we'll see later. Okay. So for the time being, just remember these names. Okay. So Nicol prism consisting of two calcite prism and they are sticked by the adhesive called Canada balsam. Okay, so there is a very important point here. So we'll see. Now the schematic diagram of Canada balsam we can see here. So first prism, the second prism. Now both the prisms are put together by Canada balsam. Good. Okay. This calcite is also calcite. Now this one is your Canada balsam adhesive. Okay. Now here, if you incident an unpolarized light, better I will use some other color. So if you incident some an unpolarized light, so unpolarized light we can graphically represent this way: dot plus double-sided arrow. The dot usually represent S polarization, and double-sided arrow is called the P polarization. Okay, so an unpolarized light will contain both uh, P polarization and S polarization. Okay, now once it incident on calcite, so this is a calcite. What would happen? This unpolarized light will divide into two parts. One of the ray is called ordinary and other one is called extraordinary. So this will divide into two parts. Okay. So one will contain only dot, other one will contain only double-sided arrow. Okay. So let us suppose so this is your ordinary ray and the upper one is the extraordinary ray. Now if you look at in case of calcite, the refractive index of ordinary ray is given by 1.66 and the refractive index of extraordinary ray is given by 1.49. And what about the refractive index of Canada balsam? The refractive index of Canada balsam is given as 1.55. Okay, now we'll get the idea. That is why we use the Canada balsam. So if you look at this calciate crystal, the ordinary ray and extraordinary ray has different refractive index. The ordinary ray has a greater refractive index, it's about 1.66, and extraordinary is 1.49. And Canada balsam has a refractive index 1.55. It is in between the refractive index of ordinary and extraordinary. So that means when the light moving from the calciate to Canada balsam, the ordinary ray is traveling from a denser medium to a rarer medium. So that is this kind of situation. So here total Indian reflection occurs because here the light traveling from a denser medium to a rarer medium. Okay, so then there is a possibility of total Indian reflection for ordinary ray because it travels from the refractive index of 1.66 to 1.55 in this interface. Okay, whereas extraordinary ray is traveling from rarer medium to denser medium, then there is no possibility of total Indian reflection. So what would occur is here we'll arrange the crystal in such a way that this ordinary ray will undergo total internal reflection. Ordinary ray will undergo total internal reflection, where the extraordinary ray will move straight without any trouble. So if you're looking from this direction, we'll get only extraordinary ray, which is plane polarized. So this is a basic idea, that is how the Nicol prism acting as a polarizer. Okay, so it uses the both these phenomena, double refraction and total inner reflection. So first of all, the double refraction split the light into two, and ordinary and extraordinary both are plane polarized. Okay, now since in the path of this ray there is a Canada balsam in between, and the Canada balsam are arranged in such a way that the ordinary ray will incident at the Canada balsam interface at an angle greater than the critical angle. So that ensures, so its geometry ensures that. Okay, so I'm not going to much details about it. If you want the greater details, you can just go to the textbook, how these angles are chosen, everything. But the basic idea is this: the ordinary ray, the angle of incidence of ordinary ray would be greater than the critical angle. So therefore, the ordinary ray will undergo total linear reflection, and the extraordinary ray, there is no total linear reflection. So the extraordinary will refract through the Canada balsam, and you will get some light, some extraordinary ray on the right side. Okay, so which is a plane polarized light. This is a plane polarized light. Okay, so this is the basic idea behind the polarization using the Nicol prism. Okay, so hope all of you enjoyed this video. Okay, so if you want the greater details, you just go through the textbook and you will get the geometry, everything, all the details here. But that is not much relevant to us. So for us, what is the basic idea is very important. It is how the Nicol prism works, and thereafter we uses it. Okay, so thank you everyone. We'll see in the next lecture with more details about the polarization. Thank you.